Now we have many scheduling algorithms, out of which the basic one or this simplest one is first come first serve. So here the model is, we are going to pick up a job. I mean, see, we are going to have, I'll just tell you this, we'll have lots of process in the ready queue. It is ready. We'll have in this pool of processes, there will be lots of them, and now there is one CPU. My assumption is that there is only one CPU here. All the scheduling algorithms, we are going to use it only one CPU. Then we have to pick one of them and give it to the CPU. Then what is the criteria that you will be looking at? First come first served. The name itself says that whoever comes first, they will get the first preference. Therefore, depending on the arrival time, we are going to pick a job and then give it. It is very simple and easy to implement also, and it is practical in the sense, even though, okay, I'll just tell you what it is. Fine. And now arrival time is used, and then mode is non-preemptive. Non-preemptive means once you choose a job and once you give it to the CPU, will finish it. I mean, until it gets finished, we are not going to remove it. And second thing is, here I'm just assuming that every process requires only CPU time without any IO time. They are all CPU time oriented. Therefore, there is no need of using any block state. So a process will be created, it will be in the new state, and it will go to the next state, which is ready running state, and then terminate, right? So if you look at the transition for this algorithm, it will look like this. It will be created newly, and then from there it will go to ready, and then from there it will go to running, and then from there it will terminate. So this is the only path that is possible. Now I am assuming that there is no IO time required, which means there is no need of a process going into the block state. And even I am assuming that there is no need of preemption, which means there is no need of these two. Got it? So only one path. Now which one are you going to choose? That depends on the arrival time. Got it? So I'll just take an example and explain you. And now we are going to use something called as Gantt chart. So Gantt chart is used, maybe if you remember it, I have used the Gantt chart even in job sequencing with deadlines. In algorithms, there is a concept called as job sequencing with deadlines. Even there I use the Gantt chart. Okay, let's see this. So these are the processes. This table says that we have 5 processes and the arrival times are like this. Process number 1 arrived at 0, process number 2 arrived at time. Okay, time 0 means what is the meaning of time 0 arrival time? It is not actual time, it is relative time. So using these numbers, the lower number indicates that it is the earliest time. So we are not actually using the real time. I mean, I'm not saying 10:30, 11:30 like that. It is just the relativeness. Relativeness means lower the number, earlier the process, like that. And then I'm going to assume that I start my CPU at time 0, and from there I am going to count the entire schedule, right? And now let's see how does it work. I'm assuming that I'm going to start counting everything from time t equal to 0. That is when I'm going to start it. So at time t equal to 0, what is the first one that has arrived? Arrival time of process number 1 is 0, which means process number 1 has arrived first. Therefore, I will give it for scheduling. Now this is the way the process are getting executed. Now, how much time does P1 require to finish its execution? If you see this, burst time is saying 4, which means after 4 it is going to finish its execution, right? And now at this point I am going to pick the next one. Why? Because you know that whenever a process finishes its execution, then we are supposed to pick up this one more process from ready state, and then we are supposed to schedule it, right? Now after P1 is over, see what is the time now? Time is 4. So by 4 all the others are available. So initially when you start it at time t equal to 0, there is only one process, which is P1, and there is no option you have to pick it. Now by the time first one has executed, which means by the time 4, all the remaining processes are in the pool, P2, P3, P4, P5. Now among these you have to pick one of them. So P1 is over already, right? So this is over, and next is you have to pick one of them, one of the remaining. What is the criteria? Criteria is again arrival time. In case if two processes have the same arrival time, then pick the process which is having lower process ID, which means if any two processes here show that their arrival time is 1 and 1, then you pick the one which is having the lower number, which means like 2 or something like that. Now at what is the next process that has to be picked up? Obviously the arrival time is showing that the next process that has to be picked up is 2, isn't it? Therefore I am going to pick up the next process P2, and it is going to be scheduled at time t equal to 4, and it requires a time of 3 units. Therefore the total units required is 7. By 7 o'clock, by time equal to 7 units, P2 gets finished, right? And then which one do you want to pick up? Obviously P3. How much time does P3 require? P3 require only 1 unit of time. Therefore from 7 to 8 we are going to give it to P3, right? And next one is obviously P1, P2, P3 is over. Next one is P4. So P4, when are you going to start? How much time does P4 require? Only 2 units, which means by 10 it is going to be finished. And what about P5? Arrival time is 4 and it requires 5 units, right? Therefore it is going to be 15. Understood this? So that is how the Gantt chart is prepared. And after preparing the Gantt chart, you could write the completion time. See, there can be various questions possible about it, like what is the turnaround time of each one, what is the completion time, what is the average turnaround time, all this. So I'll just tell you how it is going to be done. In the exam they are going to ask you for only one parameter, but here we shall see everything. Now completion time. Completion time is nothing but at what time the process is going to get completed. Watch it. What about P1? P1 got completed at 4, which means completion time of P1 is 4. P2 got completed at 7. P2 is 7. P3 is 8. P4 is 10. P5 is 15. So this is the times at which each one completed, right? And now we have started with this, and then we executed this much time, and this is the completion time. I told you that the time period between completion and arrival, right, is nothing but the turnaround time, which is nothing but the total amount of time spent by the process in the system is turnaround time. So once you have taken this, I'll just erase it. Now I'm interested in finding out the turnaround time. Turnaround time means the total amount of time that the process has actually spent in the system, right from its arrival till its completion. So the process 1 has arrived here and completed here, which means it has spent in the system a total time of 4 units. What about this? It arrived at P2 arrived at 1 and it completed at 7. Therefore it has spent a total of 6 units, right? And what about this? Arrived at 2 and completed at 8. Therefore it is 6. What about this one? Arrived at 3, completed 10. Therefore turnaround time is 7. What about this one? Arrived at 4 and completed 15. Therefore totally it is 11 units. Therefore this is the turnaround time. And once you know the turnaround time, then you can find out the waiting time. Waiting time, right? I told you that waiting time is nothing but if a process, if it doesn't have any IO request, then whenever it is in the system, it is going to do only two things. One is it is going to be in the ready state waiting for the CPU. Other is it will be at the CPU in the running state and gets executed. Therefore it has only two things to do, either wait or finish its burst time. Therefore the total turnaround time is equal to waiting time plus burst time, right? Which means I mean to say the total turnaround time is equal to waiting time plus burst time. This is the total turnaround time, right? Now if I want the waiting time, it is nothing but the total time spent by the system minus the total time it actually wants if it wants to get executed. Then what is the waiting time? Turnaround time minus burst time, which means these two. There I get waiting time. So turnaround time minus burst time. So what is it? The first one is 0. In fact, if you watch it, okay, I'll do the Gantt chart again so that I can show you what has really happened here, or you can understand this. See this? It is saying that the process P1 got is ready for execution at 0, and then it required 4 units of time, and it has spent exactly 4 units of time in the system, which means it didn't wait at all. Even if you look at that Gantt chart, the P1 got scheduled immediately, right? Therefore its waiting time is 0. Now what about P2? The total time it spent in the system is 6, but it required only 3 units of burst time. Then what is it doing for the remaining 3 units? It is just waiting for the CPU. Therefore here the waiting time is 3. And what about this one? 6 minus 1, which means it waited for 5. And what about this? 7 minus 2, it is waiting for 5. And what about this? 11 minus 5, it is waiting for 6. Okay, so If you want to understand it better, let me take the Gantt chart and explain you. I shouldn't have erased it at the first place. Let me take the Gantt chart and explain you. It will be clear. Okay. Now see the Gantt chart. It will be fast. 0, you are going to put P1 to work, and how much time is P1 going to take? 4. And then P2, how much time is P2 going to take? 3, which means 7. And then P3, how much time is P3 going to take? 1, which means 8, isn't it? And then P4, how much time is P4 going to take? 2, which means 10. And then P5 is going to take 5, therefore it is 15, right? Now watch it. How did we get the waiting time to be so and so is, see this one, for the process P1 arrived at 0 and it immediately got scheduled, therefore there is no waiting time at all. And the process P2, it arrived at 1 and it got scheduled at 4, therefore it waited for 3 units, right? Therefore that is the case. And then process P3 arrived at 2 and it got scheduled at 7, therefore waiting time is 5. And process P4 arrived at 3 and it got scheduled at 8, therefore waiting time is 5. And process P5 arrived at 4 and it got scheduled at 10, therefore waiting time is 6. Like that we get it. Understood this? So that is how waiting time is differing. And see, in this case, since it is a non-preemptive, which means once a process gets to the CPU, it will not again come back to the ready queue. That is why I am just seeing how much time it is waiting actually to get the chance for the first time, right? So that is what here is, since it is a non-preemptive, right? So in this case, even there is something called as response time. Response time is after a process gets into the system, how much time does it require, to get the CPU for the first time? That is response time, right? So in this case of non-preemptive algorithms, the response time and waiting time both are same. Even though this response time is not a frequently asked question, but still it is worth knowing about it. Response time is nothing but a process has arrived in the system and then it gets scheduled for the first time for the first time. Now what is the difference between these two times? Arrival time and it gets scheduled for the first time, and this is actually equal to waiting time in case of non-preemptive algorithms, right? So waiting time here and the response time both are actually same. Okay. And other points which are important is they will ask you about what is average turnaround time. What is average turnaround time is what is the average amount of time that each process is spending in the system. That is average turnaround time. So what you could do is you could add them all these numbers and you could divide with 5. That is average turnaround time. And then they will ask you what is average waiting time. Average waiting time is you can add these all and then divide with 5, right? So if you wanted, you could do it anyway. See, this average turnaround time is, from next time onwards you do it, you add all of them and then divide with 5, which is 4 plus 6 plus 6 plus 7 plus 11 divided with 5. And average waiting time is same, add all the waiting times and then divide it with 5, which is 0 plus 3 plus 5 plus 5 plus 6 divide with 5. Got it? So that is how we get average turnaround time and average waiting time, right? And what are the other questions possible on this? I mean, similar to this. So they will sometimes ask what is the completion time of process P3, or what is the turnaround time of process P4, like that, or what is the waiting time of process P2. They will not ask you everything, but then if they want to ask you everything, they will ask you about the average turnaround time and average waiting time. And what are the properties of this FCFS is, it will have something called as convoy effect. Okay, we shall take an example and see it. What convoy effect is, I'll take an example and show you.